Welcome protein coders, let's build some coding muscles. Today we're going to solve a problem, frog jump. It's available on GFG. What's given in the problem is we have given a heights vector, okay, and we have a frog which wants to jump from index 0 to index 4 or last index. And to jump between any two indices, the energy required is the absolute difference between the heights of those two indices. And at every index, Mr. Frog has only two options, to jump one step or two steps. Okay, on first thought you might think greedy can work. Let's see. If I start from index 0, I have two options, either go to index 1 or index 2. So I will move to index 2. It will take me 20 units of energy. Then from 2 to 3 and 3 to 4, it costs me total 90 units of energy. But let's see another way. If I move from index 0 to 1, then to 2, then to 3 and then to 4, it will cost me only 50. So greedy will not work here. That means we need to try all the possible ways. Yes, recursion. Now let's see in more detail. Suppose I am at this index ITX and I took one step. Okay. Then the energy required will be the absolute difference of the heights at those two indices. And for the rest of the indices, I want minimum energy required. So my function will be dependent on the index only, and it will represent the minimum energy required from 0 till that index. Okay. So I can write the first case as f of idx minus 1 plus absolute difference of the heights as those at those two indices, idx and idx minus 1. And for the second case, if Mr. Frog took two steps back, then what will be the total energy required is f of idx minus 2 plus absolute difference of heights at index idx and idx minus 2. So first is for the single step, second is for the two steps, and the Mr. Frog took two steps, and at the end I will take the minimum of both steps. Okay, let's write the recursive code for this. We have our cost function which will take index and height vector. First case is if idx equals to 0. That means our frog is at the 0th index block and it's want to go to that block only. So the total energy will be 0 because it's already on that block. For single step, we will write down the same recursive equation, and for the two steps also, if the frog took two steps, we will write the similar recursive relation which we have discussed above. At the end, we will return the minimum of both the steps. But there is an edge case. For index equals to 1, this will become negative, right? And in height, when we are accessing height also, this the index in the height vector also becomes negative, which is the edge case. So we need to be careful about this. idx should be greater than 1 for calculating the energy for two steps. Now let's implement our recursive solution, and we will see memoization and tabulation and space optimization in our code only. Okay, so let's jump to the question. So here is our question. Let's first get the size of the height vector. Let's call our function to calculate the cost. Let's call it cost. It will take the index. We are starting from n minus 1 and height vector. So let's define our cost function. It will take index and height vector. For the base case, if idx equals to 0, we will return 0. Then we have two cases, single jump and double jump. So we will call recursively for both the cases, single jump and double jump, and at the end we will take the minimum of both the cases. At the end we will return minimum of single jump and double jump. And for the double jump, we have to keep in mind the idx should be greater than 1, or else we will return int max because we are taking minimum of both the cases. Let's quickly compile and submit the code. Let's see. And congratulations, we got TLE. So now we have to memorize this code. Okay, let's see how we're gonna memorize it. So first let's create a dp vector, initialize to all the elements with -1. Let's pass this dp vector everywhere in our cost function also. And for early return, we will check if dp of idx is not equals to -1, we will return dp of idx. Right, we will pass dp in every recursive call, and then we will store the value of the recursion in our dp idx. That's it. Okay, let's quickly submit this. And finally, we have passed all the test cases. Congratulations. Now let's see how we're gonna convert this into tabulation code. Okay. Similar to memoization, we will have our dp vector and dp of 0 will be 0. This is from the base case. And for the for loop, I will take the help from the recursive relation. I will replace the function call with the dp and write the recursive relation as it is. So let's write our for loop. The idx will go from 1 to n, and for single step, dp of idx minus 1 plus the absolute difference of height, and for double step, dp of idx minus 2 minus absolute difference, and for this case, idx should be greater than 1. Very similar to our recursive recurrence relation, right? And at the end, dp of idx will be minimum of both the cases. And after the for loop, I will return the dp of n minus 1. The answer will be stored in the last element of the dp vector. Let's quickly compile, run and submit. And yes, we have passed all the test cases. Now, let's observe a little bit more. If you look carefully in a recurrence relation, our current value is dependent on only previous two values, previous and previous two. Similarly, in our tabulation code also, see, for single step, we just need dp of idx minus 1, and for double step, we just need dp of idx minus 2, right? So we can maintain only the previous and the previous two. Okay, we don't need to maintain the complete dp vector. So let's write our space optimized code. We will replace the dp of idx with the current, dp of idx minus 1 with the previous, and dp of idx minus 2 with the previous two. Okay, so let's initialize them. Now let's replace the dp of idx minus 1 with previous, dp of idx minus 2 with previous 2, and dp of idx with current. And now we will shift the previous values. Previous 2 will become previous and previous will become current. And at the end, we will return the previous. Very similar to the previous 1D DP questions which we have solved. Let's quickly compile and submit. And yay, we have passed all the test cases. Now let's discuss about the time complexity of each method. For the recursion case, the time complexity will be order of 2 to the power n, because we are calling recursion 2 times for every case. And for memoization, it will be order of n. And for tabulation also, it will be order of n, because we are solving every sub problem only once in both the cases. And for the space complexity, all of them will take order of n. And for the recursion, it will take recursive stack of order of n, right? And for the space optimized method, the time complexity will be the same because of the for loop, but the space complexity will be order of n. So that's all from my side, guys. You will find the problem and the solution link into the description box. If you have any queries, please mention them into the comment box. I hope this helps. Let's meet in some other video. Till then, keep smiling, keep practicing. Thank you.